to start talking about more complex circuits. And a complex circuit, we're going to say, just has more than one resistor. Now, there's two rules that we can use for any complex circuit. There are series circuits, there are parallel circuits, and then there's combinations, which are a lot more complicated. But this junction rule and this loop rule will apply to any of them. And the junction rule is basically a conservation of charge rule. And we're going to state it this way. The current into a junction. Okay, a junction is where things meet, so where a couple wires meet, must equal the current out. Okay, that's pretty straightforward. If I have 3 amps going into a junction, I have to have a total of 3 amps going out. Because charge is conserved. So my example might look something like this. I might have a wire here meeting 2 wires here where they're going to split. Let's say I have a current of 8 amps going through this one, and actually I'm going to put a 4th wire in here. Alright, and I have a current of 3 amps going this way in this wire, and then I have a current of 6 amps going here, and I want to know what's happening in this wire down at the bottom. So I'm trying to find that current. So what I do is I look at each thing, in and out. I'm just going to add up the ins and add up the outs. So that 8 is going in. Okay. I have the 6. Look at this junction. It's going out. It's going away from it. So I have 6 going out. I have 3 going out. And then I have I, which is what I'm looking for. So right now I have a total of 9 going out and only 8 going in. Therefore, I must be 1 amp going into the junction. So it's a very straightforward rule. Second one is the loop rule. The loop rule is a conservation of energy rule. And our voltages are related to our energy, so this has to do with voltages. And the rule is going to say that the sum of voltages around any loop is equal to 0. Another way you can say it is voltages gained, or voltage gained in the battery will equal the voltage lost in the resistors. So an example for that might look like this. I got a resistor here, a resistor here. I'll make this even more complicated. A resistor here, and a resistor here. And I'm going to say the voltage here is 20 volts. I'm going to put a voltmeter across this guy. Call that V1. I'll put a voltmeter across this guy. V4. Okay, I'm going to say if V1 equals 15 and V4 equals 2, then I'm going to hook up some unknown ones over here. Call that one V2, call that one V3. What are V2 and V3? So this says any loop, the voltage gain in the battery is going to be lost in the resistors. So I can do a couple different loops, but I'm going to start out by looking at the leftmost loop. Okay, so I'm going to go around here like this. And that'll give me back to the battery. So it comes out of the battery, goes through the first resistor, goes through the second resistor, and then comes back to the battery in that loop. So it's going to be 20. The voltage gain in the battery equals what's lost in the resistors. So V1 is, so I'll do it this way. V1 plus V2. I gain 20 in the battery, I lose something in V1, lose something else in V2, and it has to add up to 20. So then 20 plus, equals 15 plus V2, so therefore V2 equals 5 volts. And then I will do the outside loop. Okay, for the outside loop, current's going to come out of the battery. It's going to go through V1. It's going to go through V3. It's going to go through V4 and come back like that. I'm going to do the same type of thing. It's going to be 20 equals, I go through V1, then I go through V3, then I go through V4. So 20 equals, we were told that V1 is 15. Plus, we're looking for V3, and we said V4 is 2. Up here, that was given. So now that's going to tell me V3 equals 3 volts. So those laws are pretty straightforward, and they're going to be really important as we move along.